Persons, you need to unmute your mic so we can have a discussion, right? So we won't just be on the class and expecting others to speak while we listen. So we are gonna communicate and see how best we can actually get the class going. All right, so as
So
it
natural
go again, sorry.
numbers are also called counting numbers, and they are spread from 1 to infinity.
All right, so would somebody actually read through the notes? All right, in terms of even numbers for now, we're not gonna explore even numbers as yet. So you're saying that, so we're gonna look at natural numbers, whole numbers, and also integers. That's the three I sent in the notes. All right, so what were you saying about natural numbers again? Natural numbers. What were you saying about natural numbers?
They are also called counting numbers.
All right, so also called counting numbers. All right, good. So I'm pulling this from you before I go deeper in the explanation. And I will adjust the pen as time passes because probably you're not seeing the best quality writing now, but don't worry yourself. Right, so also called counting numbers. You said something again after that. What was that?
And positive integers.
All right, counting numbers, positive integers. All right, let's put that down. Anything else? Anybody else? Just you said something interesting, man, that I want you to try and remember. See if you can remember what you actually said after you mentioned they are also called counting numbers. You said something again after that. You can remember? They go from what?
So they start from 1
From one.
and so on, go to infinity.
All right, good. So they start from one and go straight to infinity. All right. So this, well, this is the symbol that is used to represent infinity, right? I will spell it INFINITY. Do you have an explanation in terms of this concept? What is infinite? What do we mean when we say infinity? What does it mean? What does the word infinity mean? So it starts from one, goes straight to infinity. What does that mean?
It goes on, never
Uh,
stop.
all right, good. So anytime you see infinity like this, it doesn't have any end at all. It just go on and on and on, and it don't stop. So right, so we are going at this now, but we just touch the surface right here. So as what you say, it go on and on and on. 1, 2, 3, 4, and don't ever try count out all of these numbers right here. So because may I tell you, you will never come to an end in terms of stop counting. All right, so we're gonna move the other ones now, or each of them in more detail. All right, so the notes that I have here is basically the same thing that I sent in the WhatsApp, right? So you don't have to write this off. I'm just gonna explain what this basically, what these things basically mean. All right, good. Let me see now. Go back to good. So first thing that she said, so natural numbers are counting numbers, right? Realize I say are counting numbers because natural numbers are also called counting numbers, right? So they are the most basic type of numbers. They start from one and go on to infinity, right? Just as what you're reading in your notes. So for example, when you're much smaller and somebody asks you if you can count, right? And if it's a case where you're able to count, what are the numbers that you repeat? Or what are the numbers that you would count? If somebody asks you if you can count and you say yes, we can count, and somebody say, all right, count for me. What are the numbers that you would tell them? Come, tell me so I can write them down here. What are the numbers?
1, 2, 3, 4, 5, 6, 7, and
All
10.
right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That are the first set of number will come to your mind. Not sure when somebody asks you if you can count. Right? So
Yes, sir.
right, so this basically it seemed natural to go to this as the first set of number. That's why they name natural number. You get what I say? Right, that's why they are called natural numbers. That's basically where the concept of natural come from. That's the first set of numbers you would go to actually count to 10. Alright? And they are also called counting numbers, numbers that you use to count. So whenever you see natural, you think about counting, same numbers you use to count. They start from 1 and go straight up to infinity. And somebody says infinity means that it doesn't have an end. Alright, so let's not try and count out all of this. So we could just hold on there. Let me, give me a sec, please. Give me a second. I'm just here, man. Somebody just asked me something. Okay, back here again. So let me rub off this. Alright, tools. Good. So start from 1 to infinity, and they are also called positive integers. We're gonna explain this part of it now. Positive integers. Alright. So we got a few things from this now. We know that natural numbers are also called counting numbers, right? What else did you get from this that we went through? What else did you get from it? Come on, several persons responded earlier. So what else did you get from this set of notes? So we said they are also called counting numbers. What else you understand again from it? So everybody gone silent already.
Sir, it doesn't have an end.
Sir, they are represented by the symbol N.
Alright, doesn't have an N, represented by the symbol N. Alright, good. The symbols are always capital letters, right? Represented by the symbol N, and that's a capital N. Alright, so examples now. So whenever you write, so if I ask you to write a set of natural numbers or counting numbers, and we say example, you just put N equal. You don't have to put natural numbers or counting numbers, You just, because N already represents the set of natural numbers, right? You just say N equal, and you start to put them out. 1, well, start from 1. Always start from 1. 1, 2, 3. Remember, don't try count out all of this now. Why you must not try to count out everything for natural number?
Sir, because it doesn't have an end.
Exactly, right? It has the infinity concept to it. It doesn't have an end. So if you say I try count out all of this, you go to count so till years pass and you still a count. So how we do this now? We can put 1, 2, 3, and then we put these right here. Right? You see those three dots? Right? We call
Yes,
them
sir.
right, we call them ellipse. So we can put that means say it continue. So if I ask you to, unless I ask you to write the set of natural numbers going up to a certain point, then you can include it specifically. But the and so on right here basically means that it goes on in the same pattern. Doesn't have an end. Any questions or any problem with this that you want me to go over?
No, sir.
All right, so natural numbers, that is. Which other number did we look at again? Let me see if you remember what I sent you. What's the second type?
Whole numbers.
All right, good. Next page now. I shouldn't even tell you that yet. I shouldn't even go over them. But you have the same thing in your notes still, so nothing wrong. All right, so I'm going to explain whole numbers now. And remember, guys, you don't have to write this. It's the same notes I gave. I'm just explaining it much better. So, for whole numbers now, what are you understanding from the whole numbers? Read it and tell me what you understand from it. Before I tell you. For whole numbers. Let me put on an S up here.
Sir, it's the same as natural numbers, but it starts at 0.
All right, very good. So, whole numbers are the set of natural numbers, right? Including 0. So remember we just covered natural numbers a while ago, you know. So if we go back to natural numbers now, we know that natural numbers start from what?
1.
1 and goes up to where?
Infinity.
Infinity. That means, right, it not stop. Bam, bam, bam. So if we go back to whole numbers now, we are seeing that whole numbers are the set of natural numbers. So give me a set of natural number now. So natural number would be equal to what? You're gonna tell me. What should I write?
0, 1, 2, 3, 4, 5.
Hold on. Remember, we're looking at natural numbers, you know. This part. Let's take a pin right.
1, 2, 3, 4, 5.
Yes, I want you to get that out first, because once you know the natural numbers, it's very easy for you to get the whole numbers. So natural numbers would be what? 1, 2,
2, 3, 4, 5.
2, 3, 4, 5. Stop at 5. Remember, you have to put your ellipse to state that it goes on and it never stops. You could have stopped at all 1, 2, 3 or 1, 2, 3, 4, you know. But you have to put these 3 dots right at the end. Right? It continues. Right, so if these numbers represent natural numbers, and they say whole numbers are the set of natural numbers including 0, what would be the whole numbers now?
0, 1, 2, 3, 4, 5,
Right.
and the ellipse.
Right, so good. So the only difference between the natural number and the whole number is that we start with a 0. Right, so we start with a 0. So 0, 1, 2, 3. You can stop at any number. That continue. And whole numbers still go on to infinity, because the only difference between whole numbers and even numbers is what? The only difference between whole and even number is what?
0.
Exactly.
The 0.
Right. The whole number has a 0 at the start of it. Alright, so I think that would be the example that we would have put right here. Right, so if I ask you to write a set of whole numbers and I give you a certain place where you should stop, or I give you some restrictions in terms of what you should write specifically. You would just write, let me get a different tool. So for whole numbers, you don't have to write out this word, the term whole numbers. You just put your W like this, equal, because the symbol, right, is W. Whole numbers are represented by the symbol W. So if I ask you for the set of whole numbers, you just put your W and then put your bracket and you start list them over here. So give me a set of whole numbers now. Come on, give me the example. It's all over the
0, 1,
right.
2, 3, 4, 5, dot, dot, dot.
Alright, now go. Alright, you give me back this here, man. But nothing wrong, nothing wrong with that. Say 0, 1, 2, 3, 4, 5. This dot. Refer to them as ellipse. Alright, which other type of number we look at?
Integers.
Alright, somebody remember what I want. What are integers, by the way? Before me even go over to the page, let me clean up this part in the meantime. Hold on. What are integers? Look at the notes and tell me what you understand from integers while
They are the set of whole numbers and negative natural numbers.
Alright, I know. Yeah, wait, tell me what you understand from that before I even go over to the page. So there are this set of, let me put in another, let me try get the next page. Hold on there. Oh, hold on. I don't like this this white page. This is actually giving me a different setting from the one I set up to teach you. So while I'm teaching, I have to be getting used to this type. This is a different version. It just updated probably a few minutes ago. Alright. But that now I'm gonna stop the class anyway. So what is it about integers again? So integers are what? What is it integer be again? Come on, student, man.
Are the set of all whole numbers and the negative of natural numbers.
Alright. So we know how whole numbers look, not true? Where whole numbers start?
From 0.
From 0 and go which part? Where does it end? Or does it have an end?
Infinity.
Right?
0 doesn't have an end.
Alright. And for persons who just joined the class, the concept of infinity means that something is unlimited, it does not have an end, and it just goes on and on and on. So whole numbers in this case, we can describe it as being infinite. Right? So infinity would be the noun that names the concept, and infinite would be the adjective that describes the concept. Alright? So infinity. Alright? Infinity. So this would be the noun, right? Right, and then infinite is the adjective, right? ECT. Run out of space, but you understand what I want. Adjective. So in describing whole numbers, we use this one. Whole numbers are infinite because we are describe the characteristic of whole numbers. So we say it infinite. So we understand what just go on like a while?
Yes, sir.
Alright.
Yes, sir.
Yeah man, we sound
Yes,
where
sir.
we're going. Good. Alright, so back over here so again. No time now. Alright, we soon finish, man. Let me get off this. So pen again. So we say integers can comprise of all whole numbers, right? So let's put down the whole numbers right here. So 1, 2, what we had above. We can stop at 3 to once we have a 1, 2, 3. That once we have an ellipse. All right, and then hold on, let me go on the page. Go on the page. All right. All right. So let's put down the so integers are all the whole numbers. Let's look at this part first. All the whole numbers. So we know what whole numbers are. Whole numbers starts at 0, 1, 2, 3. We can stop at 3. That, which is your ellipse. That's the whole numbers. So we get out this part of the definition already. Whole numbers and the negative natural numbers, right? The negative natural numbers. So every number that you know that which is natural, where does natural number start?
From 1.
All right, good. Natural number starts at 1, right? 1, 2, 3, and it goes on to infinity. So if this says the negative natural numbers, this word right here, so negative natural numbers, you're going to turn all the natural numbers into negative. Understand? And if they are
Yes,
negative,
sir.
right, if they are negative, they're going to be over this side, over the left-hand side of 0, right? So it's a negative natural numbers. We know the natural numbers already. So we say, all right, 1, negative 1, negative 2, negative 3, right? And we still use the ellipse over here, so because it continues into that direction as well. So on this side, what does this ellipse mean? This ellipse mean? What does it mean? Which concept?
It goes on and on.
Right.
It doesn't end.
Right. So this ellipse right here, this presents the concept of infinity. But look at this now. 0 is in the middle right here, right? And we have positive numbers over the right hand side and negative numbers over the left hand side, right? So in terms of infinity, this side has to be positive infinity right here over this side. And what would this side be?
Negative.
Infinity.
All right, good. Negative infinity. Because integers, they continue in both directions non-stop. Positive side and negative side. And the number line is a very common example of how this is represented. So the 0, we're going to do future classes on number line. 0 right here in the middle. Positive over this side. 1, 2, 3, 4, 5. You see this arrow right here, so? It means that it not stop. It indicates the same concept as the ellipse. The arrow means that it don't stop, it continue. Right, and over the left hand side, so over this side we have positive infinity, and on the left hand side now, negative 1, negative 2, negative 3, negative 4, negative 5. This arrow right here presents the same ellipse concept as well, and this side is negative infinity because it continues non-stop in both directions. You go on and on and on. Do not try to count it. All right, good. So any questions on the types of numbers that we have covered so far? I think this is the final slide that I'm going to review. Remember, I'm going to explore even numbers further. So any question before the activity? I heard somebody knocking. Let me see. Any question before we move on? Anything you want me to go over?
No, sir.
Sir, why the definition could it be involves all sorts of both positive and negative whole numbers?
Let me see. Let me go back. Let me go back this and I'll go back on my page. Hold on. Go on again. Repeat that, please.
So why couldn't the definition be that integers are the set of both positive and negative whole numbers?
All right. Watch out now. of both positive and negative whole numbers, right? Let me clean off some of this. Hold on there. Hold on. All right. Good question. Good question. All right. So remember, we said whole numbers start from where? Whole numbers start from what?
0.
All right. 0, 0, 1,
Yes, sir.
2, 3, which is the ellipse. And you're asking that why we couldn't say integers are negative and positive whole numbers, right? Am I correct? Am I correct? Person who asked the question, you're saying that why
Yes, sir.
the definition couldn't just
Yes,
say
sir.
integers are negative and positive whole numbers. All right, good. Remember now, this set of numbers right here represent the whole number set. Everything right here, so. And you're saying that why we couldn't say it was just negative and positive whole numbers. This is the reason. 0 is included in the whole numbers, and 0 is neither negative nor positive. So if I say the set of integers is basically the set of negative and positive whole numbers, I am basically saying that there is a negative and a positive 0. And as I said, 0 is neutral. It is in the middle. It is neither negative nor positive. Understand? Provided any clarity to
Yes,
that?
sir.
All right. We're still gonna go back through that concept in terms of revision when we are probably the next time that we have class. But any other question before I move on? Well, I'm gonna close out the live class for now, but I'm gonna send you the activity that I have that relates to all that we just covered right now. So if you don't have any more questions, then I will close this out and send you the activity on WhatsApp. All right?
Yes, sir.
All right. Take care. I'm gonna send it now.